I wanted to spend a couple minutes talking about some changes that I made to the Contact Manager application, kind of in anticipation of some changes that we'll make to the EDM address book manager so that it will make changes in real time. Essentially, we won't be loading and saving all in bulk. We'll be making the changes as they occur. And in fact, we'll be reading from the database as we request address books. But those changes required, or that change requires that I did some upfront work. I didn't want to get rid of anything, but I did want to go ahead and clean things up a little bit and separate out some functionality so that we kept only the functionality that we needed in each individual class. Alright, so if we look at this diagram here, what we're looking at is a modified version of the application. And if you recall, we had these three classes: ADO Address Book Manager, Serialization Address Book Manager, EDM, Unity Data Model Address Book Manager. And all three of them implemented essentially the same concept. We had a backing dictionary that held all of our address books, and then some common methods for adding and removing address books, for getting individual address books, and for running through and allowing ourselves to query those address books or run a for each through all of them. If you looked at the code, in fact, they were identical for all three, and so that sort of told us that that was a pretty good candidate for abstracting those concepts out into a common base class. And so I did that. I created a Memory Address Book Manager base class. Okay, it's an abstract class, meaning you can't actually create an instance of this. There's actually no reason why we can't, but I went ahead and made it abstract to force us to create one of our concrete implementation classes of this. Alright, so now I've got ADO Address Book Manager, Serialization Address Book Manager, and EDM Address Book Manager all inheriting from the parent Memory Address Book Manager. So they all inherit this backing field. They inherit all of the methods for pulling information out of or putting information into this dictionary. And really the only things that they implement now are the pieces of those classes that were different, specifically the need to load an address book differently depending on whether you're doing it from ADO, serialization, or EDM, and saving the address books. The other major change that I made was to change these interfaces a little bit. Prior to now, we had an iAddress Book Manager interface that included not only the interactions with the sort of in-memory address book dictionary, but also a need to load and save the bulk, I guess, the entire address book collection. In preparation for a future in which the EDM Address Book Manager does not actually load and save all at once, in fact we're going to do those dynamically, what I did was I pulled out the two methods for loading and saving into their own interface. And so currently all three of these implement these, because the way that we actually did the implementation for EDM Address Book Manager, currently it loads everything into the dictionary and saves the changes back. But we are going to change that, and so I wanted to make it so that this interface could be implemented by these two, the ADO and the Serialization Address Book Manager, because they truly were going to load and save. And then I could do my own EDM Address Book Manager that really probably doesn't inherit from Memory Address Book Manager anymore. It just implements this iAddress Book Manager interface. And by doing that, I will be able to fairly easily make some minor changes in my code to support both types of Address Book Manager, both the kinds that save and work from an in-memory dictionary and the kind that work in real time, reading information from the database and saving it as changes occur. So briefly, let's look at the code changes that I made. First of all, we can take a quick look here My iAddress Book Manager, I had to remove the two methods. I think they were at the top up here. Alright. I did create an iSaved Address Book Manager. So here is that. I just put these two load and save address books there. Okay, so let's look at one of our address book managers, and I did this for all three. Essentially, what you have to do is come in here and say the address book manager now inherits from, and this is the new class that I added that we'll look at in more detail in a second, it inherits from memory address book manager, but it also implements this iSaved address book manager. Okay, so we're saying that this particular version, ADO address book manager, is a type of memory address book manager, and in addition it can be saved and loaded. And really the only other changes that I made were to remove all of those methods and the public field, or the private field, the backing field, from this class. Okay, so now this class only contains the load and save logic for this particular type of contact manager. I did the same thing for the EDM address book manager, at least for now that's going to stay the same, and I did exactly the same thing again with the serialization address book manager. All three of them implement or extend the memory address book manager class and implement the iSaved address book manager. Let's take a closer look at our base class now. I scroll up to the top here. A couple of things changed. Now I artificially made this abstract, meaning that you can't create an instance of this. I actually could take that out and we could use this class for testing. We'll leave it abstract for now, but the reason you would label something abstract, there's two reasons. One, you want to force somebody actually not to create an instance of this class, a concrete instance of it, instead to create an instance of the subclass. And two, if you want to include some pure abstract methods, so you want to force your subclasses to implement certain methods, you can declare your base class as abstract as well. I did actually come through and make sure that this class, this base class, does the implementation of iAddress Book Manager. And if you remember, I removed the save and load methods and put them into a different interface, so now my base class here can actually do all of the stuff that I want it to do as far as the base address book manager functionality, the find, the add, the remove. Okay. Everything else is pretty much taken directly out of one of our three address book manager classes, all of the common code. So I've got my protected dictionary here. Now this is one change that I made that needs to be noted. This was private. I kept that internal. So it meant that nothing outside of this particular class could access this variable. I didn't want that anymore though, because I want my subclasses to be able to get access to this dictionary. When I'm doing my save and my load logic, they have to have direct access to the in-memory dictionary. So what I did instead was I labeled as protected. Now protected basically means that I can access it from inside of my class or from inside of any of my subclasses, but it's still essentially private. It's not a public field. The only way you can actually get access to this is to inherit from the class. So that was a pretty important change. If I'd have kept it private, even my subclasses would not have been able to manipulate this address books variable. But everything else is exactly the same. I had to change my constructor to be a memory address book manager constructor as opposed to an ADO address book manager constructor. I did do one other thing though. I also came through and added a virtual keyword in front of all of my get methods, all of my delete methods, all of my add methods, and I did that so that I could, if I needed to, override these methods in my subclass. If you don't put virtual in front of these, you don't have the option of overriding these methods. By putting virtual there, at least gives me the option in a future iteration if I wanted to make my ADO address book manager behave slightly differently when it got the address book address books. It's probably not going to happen, but it's a good practice when you're creating a base class and you think that it's possible. You might want to change the implementation slightly in your subclasses. And that's basically it. Now I did have to make one more change to my main form. Because I moved the save and load logic into the iAddress or iSaveable address book manager interface, I had to put in some logic to check to see whether the particular instance of the book manager, the iAddress book manager, remember we're treating the book manager as the interface, I had to check to see whether that particular instance of the iAddress book manager also was a savable address book manager. So I have this if statement here. If book manager is iSaveable address book manager, if it is, then I'm going to save it, or I'm going to load it in this particular case. So I couldn't just do book manager.load address books because book manager is being treated as an iAddress book manager. I had instead to cast it, and we've done this before, but I had to take that variable and I had to cast it as a savable address book manager so that I could then call its load address books method. Did exactly the same thing down here for the save, but every other thing in this solution stayed the same. What this has done now is it's allowed me to have two different kinds of address books, or address book managers. Ones that can be saved and loaded all in bulk, and ones that do their stuff, their gets and their deletes and their adds, dynamically in real time.